Hello everyone, this is lesson 10.4, Inscribed Angles. So the first thing we're going to do is a GeoGebra activity. So if you want to go to geogebra.org/geometry and follow along with me, feel free, or just watch and take notes. So the first thing we're going to do is select the circle with center tool to construct a circle. So this button right here, I'm going to click and move my cursor out and then click again to finish the circle. And then we're going to use the segment tool to construct two radii going from the center to the outside of the circle, forming a minor arc CAD. So I'm going to use the segment tool. I'm going to click on C and then a point here, and then, sorry, I meant A, and then A, and then a point here. So this minor arc is formed by the sector CAD. And then we're going to use the point tool to construct 3 points on the circle in the exterior of angle CAD, so this part here, such that they are labeled E, F, and G. Okay, so I'm going to go E, F, G, and then use the segment tool to draw the chords EC, so EC, ED, there's ED, and then FC and FD, FC and FD, and then guess what? GC and GD. So we've got angle CED, angle CFD, and angle CGD. Then we're going to right-click on the corresponding chords to change their color to be the same. So EC and ED, if I right-click on this, click on Settings, Color, maybe I'll choose this color, whatever, pink. Okay, I don't know if that saves automatically. Yes, it does. Okay, so I'm going to say the same thing for this one. Same color. And then these two, I'm going to make a different color. Maybe green. Oh, that's not what I wanted. I tell you, GeoGebra keeps... Oh, no. Go back. GeoGebra has since kind of changed some of their settings around since I've done this last year. So hopefully we can get this to work. I'm going to do this one. Green. Okay. Maybe I was just not clicking on the right one. And then these two. How about blue? Light blue. Oh, I can't. Here we go. That's light blue. Okay, so we've got our three different arcs, or three different angles here. And notice that the vertices of these angles are not in the center, but they are on the circle. That's called an inscribed angle. A central angle is angle CAD. That is called a central angle because the vertex is at the center. These three angles are called inscribed angles because their vertices are on the circle, and the angle is inscribed within the circle. Okay, so we have the other thing. Okay, so we have created three inscribed angles. That one, and that one. I'm just trying to follow along on this paper here. Now we're going to use the measure tool to measure each angle. So click on More, scroll down to Measure an Angle. So I'm going to measure angle CED, it's 25.7, CFD, 25.7 again, and then CGD, guess what's going to happen? 25.7 again. So here's the thing. Also, if we were to move points C and D around, so if I were to move this this point around, make this arc here bigger, they stay the same. I make it smaller, they stay the same. Make it bigger, they stay the same, as long as it's a minor arc. Okay, because or else we're kind of just changing the problem. So the thing about inscribed angles is that any inscribed angle that shares an intercepted arc, we call this an intercepted arc, is congruent, no matter where this point lies. Okay, so if I drag these points around, they're going to stay the same because they are still intercepting the same arc. Now, I wonder if we can find the measure of an arc. I wonder if it'll let us find that. I'm not too sure. I wonder if we could... No, that won't let us find the measure of the arc. How can we find the measure of the arc if we found the measure of the central angle? So I'm going to go out of that, go back to the measure, CAD. So if the measure of central angle CAD is 53, then the measure of the arc is 53. And guess what? If you take 53 and divide it by 2, you get 26.5. Okay, so also the measure of the inscribed angle is half of the measure of its intercepted arc. All right, so we're going to talk about all of these things. So now you can find your notes. If you are not in person, I haven't started including the notes in the folders for the day the video was assigned. So this would be in the Friday folder. All right, so an inscribed angle is an angle whose vertex is on the circle. So DAB, ABC, BCD, etc., and whose sides contain chords of the circle. An intercepted arc is the arc that lies in the interior of the inscribed angle and has endpoints on the angle. So if we, for example, if we were to look at angle BAD, what would its intercepted arc be? Well, if we're looking at this angle, its intercepted arc goes from point B to point D, so all the way around here. So its intercepted arc would be arc BCD. I'm not sure if that's major or minor arc, but I would just name it BCD just in case. So number one, angle BAD is an inscribed angle. So BAD, that's what we just answered. So arc BCD. And then number two, name another inscribed angle and its intercepted arc. So how about ABC? So angle ABC corresponds to arc from A to C going around this way. So ADC would be its intercepted arc, the arc that the endpoints intersect. Okay, an inscribed polygon is a polygon where all the vertices lie on the circle. Okay, an inscribed you can think of like inside, like an inside polygon, and then all of the vertices of the polygon. So A, B, C, D, that would be an inscribed polygon. And then a circumscribed circle is a circle that contains the vertices of an inscribed polygon. So this would be a circumscribed circle because there's an inscribed polygon within it. And remember, an inscribed circle is like if you have a rectangle and then if you have a circle that's points are on, or that's an radius is like on the inside of the polygon. Okay, moving along. So a couple theorems here. So the measure of an inscribed angle is what we talked about. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So the measure of angle ADB is 1/2 of the measure of arc AB. And we'll call this 10.4, kind of like what we did in the last lesson. If two inscribed angles of a circle intercept the same arc, then they are congruent. So two inscribed angles, so that's basically what we did here. We had 3 inscribed angles and they all intercepted the same arc, so they were all congruent. So for example, there's a couple different situations here. We could look at arc PQ. So if you look at angle PSQ and PRQ, they both intercept arc PQ, so they're congruent. If you look the opposite way at arc SR, you've got angle SPR and angle SQR. So those are also going to be congruent because they both intersect arc SR. Oh, we'll call that 10.4b. 10.4c. And if a right triangle is inscribed in a circle, so a right triangle, then the hypotenuse is a diameter. Well, how do we know that? Well, let's look here. A, B, C. So we've got a right triangle. We know it's a right triangle. Therefore, this angle must be 90 degrees. And if this is 90 degrees, then the intercepted arc is twice that, so 180. And if this is 180, then we know that the hypotenuse must be a diameter because that creates a semicircle. Okay, so that's how you would explain why. So AC is a diameter. Quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And there's another interesting reason for this one. So we're looking at here and we're saying the opposite angles, so D and F are supplementary and E and G are supplementary. So how does angle D relate to arc EFG? So angle D, EFG, it's 1/2 of the measure of arc EFG. Okay, so whatever this is, angle D is 1/2 of it. How about angle F? Well, it's 1/2 of the measure of arc EDG. So the other part of the circle, it's not exactly half and half, but it's one part and then the other part of the circle, which makes the whole circle. So if the measure of both of these arcs together is 360, then the measure of arc, and they're not exactly split in half, but the measure of arc D and angle D and F, therefore must be half of that, which is 180. Therefore, whatever they are, they must be supplementary. So it's the same thing for E and G. You could do the same kind of reasoning for that. And we'll call that one 10.4D. All right, so a few examples. Angle S intercepts arc blank. That would be arc RT. Therefore, the measure of angle S would be 30 degrees, half. Angle R intercepts arc, question for you, QS. Therefore, the measure of arc QS must be what? Well, 37 times 2 is, what, 74? And then how about the measure of arc RQ? Well, this is 74. RQ, okay, so we've got an important thing here. This is a diameter. So if that's a diameter, this adds up to 180. Therefore, this must be 120. So if you do some math and subtract 360 from all of these guys, well, actually, what you could do is just do 180 minus 74. And that would give you 106. 106 degrees. Number 2, the measure of arc HJ. So here's arc HJ. It's intercepted, one of its angles that intercepts it, because there's 2 of them, would be this angle here, which is 37. And therefore, the arc measure would be twice that, so 78. How about the measure of angle HGJ? So this angle right here. Well, it intercepts the same arc as this angle, therefore they must be the same. So 39. Okay, number 3, the measure of arc AB. So how about that one? Well, we know that this is a right triangle since this is a diameter. So therefore, this angle here must be 40. And then since this angle intercepts arc AB would be twice this angle, which is 80. How about angle NPO? NPO, we're talking about this angle here. So one of the things that you can't assume is that this arc is the same as this arc and 68 is the same as this arc. So those are not necessarily the same. And in fact, they're not. But what we do know is that if we take 180 and subtract from 118, we can get arc PQ. So 180 minus 118 would be 62. Okay, so if you assume that they were the same, then you would have been off. So if that's 62, this arc would be 180 minus 68, which is 112. Okay, so we're asked to find NPO. NPO, I probably did a little more math than I really needed to, because NPO intercepts this arc, so that would be half of 112, which gives us 56. Measure of angle A, so this angle here. So in order to know this angle, we have to figure out this arc, but this arc is also intercepted by this angle, which is 73. Therefore, these two angles share the same intercepted arc, so they must be the same. So that's 73. All right, a couple more. Name two pairs of congruent angles that are not vertical angles. Okay, so they're saying like just don't name these ones. All right, so we could do P and Q. So angle P congruent to angle Q because they both intercept arc SR, or we could say angle S and R. 7. In a right triangle, if a right triangle is inscribed in a circle, let's do a little visual, and if it is, then that means the hypotenuse is the diameter. So we'll do a little diagram here. Wait a minute. No, I'm drawing this the wrong way. Okay, how about that? Okay, the radius of the circle is 5.6, therefore the hypotenuse would be 11 point, what's 5.6 times 2? Okay, yeah, 11.2. And then what is the length of the hypotenuse of the right triangle? Oh, that was it. That was the question. Okay, that was easy. Okay, and then that was related to theorem. If you go back to your theorems, that was related to 10.3c. Find the value of each variable. Okay, so this is using 10.3d, where the opposite angles in an inscribed polygon are congruent. So y would be 80, and x would be whatever 180 minus 88 is. I think it's 92. 92. And then here, so in order to find these, we're going to use the fact that the inscribed angles are 1/2 of the measure of the intercepted arc. So the thing is, though, that x is inscribed by, or intercepts arc from F all the way to H. So we would have to do 108 plus 75. So 108 plus 75, and then divide it by 2. So it's 103 divided by 2 is 91.5. That is what x is, 91. And then y is the angle that intercepts the arc from this point, which I can't recognize anymore, to that point. So we would do the same thing. Add up 108 plus 104 divided by 2. I'd probably do this in my head if I tried hard enough, but it's too early. 106. And that would be equal to y. Okay? So that is the end of this lesson. You learned about inscribed polygons and inscribed angles and how they are half of the measure of the intercepted arc, whereas central angles are equal to the measure of the intercepted arc. Okay, and then you learned 3 other theorems about the inscribed angles sharing the same mark are congruent, and then a right triangle that's inscribed in a circle, and then also the opposite sides of a inscribed polygon are supplementary, or the opposite angles. Right, so that is all. Hope you guys have a great day.